Hello viewers, in today's class we are going to solve yet another important and conceptual problem from limits and continuity, right? And here once again we'll take a very conceptual problem, and here we have to discuss the continuity of this function fx is equal to x minus greatest integer of x at x is equal to half, right? So we have to test the continuity of this function when x is equal to 1 over 2, right? So here the function which we are given is x minus greatest integer of x, and we know that x minus greatest integer of x is our fractional part function, right? So we can write x minus greatest integer of x as fractional part of x, right? So here we can discuss the continuity of the fractional part function by graphical method, right? But here we'll prefer the analytical method, right? So here we'll solve or we'll discuss the continuity of fractional part function at this point, that is x is equal to half, right? So here the point which we are given is not an integer, right? So let us start, right? So first of all we'll see that the domain of the fractional part function is the set of all real numbers, right? So we can have the domain as the set of all real numbers, right? And the range of this fractional part function is given by this interval, that is 0 comma 1, right? So here the range can be written by this inequality. So here we have 0 and here we have 1, right? So the range lies between 0 and 1, including 0, right? So to discuss the continuity of fractional part function, what we will do, we'll first find the right hand limit, then we'll find the left hand limit, and then we'll find the value of the function at this point, that is half, right? So let us first find the right hand limit. So now the notation for the right hand limit is the limit x tends to half, and here we'll put a positive sign, and here we have f of x, right? So here we have the point x is equal to half. So when we find the right hand limit, we are approaching towards half from the right of x is equal to half, right? And when we find the left hand limit, then we approach from the left of x is equal to half, right? And here we'll take 2 points in the neighborhood of x is equal to half, and the point which lies towards the left of x is equal to half is half minus h, and this point which lies towards the right of x is equal to half is half plus h, right? So here we have limit, and x tends to half plus f of x can be written as the fractional part of x, right? So which can also be written like this: x tends to half plus, and here we have x minus greatest integer of x, right? So now what we will do here, we'll take x is equal to half plus h, where h is a very small quantity, but it is a positive quantity, right? And h lies between 0 and 1, right? So when x tends to half, then obviously h tends to 0. So now this limit can be written as limit h tends to 0, and here x can be replaced by half plus h, and here we have minus greatest integer of x. So here for x we have half plus h, right? So now we can simplify this expression. So we have limit h tends to 0. Here we have half plus h, and here we have greatest integer of half plus h, right? Now, since h is a very small quantity, right? So h is infinitesimally very small. So half plus h is slightly greater than half, right? But this quantity half plus h is less than 1, right? So from the definition of greatest integer function, the value of greatest integer of half plus h is equal to 0, right? So the value of this greatest integer of half plus h is 0 because half plus h is slightly greater than half, but it is less than 1, right? So here we can write 0, right? So now we have limit h tends to 0 and we have half plus h. Now we can here safely substitute h is equal to 0. So we have half plus 0, that is equal to half. So the right hand limit is equal to half. So here we can write half, right? Now let us calculate the left hand limit. So the left hand limit can be written as, the notation is limit x tends to half, and here we'll put a negative sign, and here we have f of x, right? So now this can be written as limit x tends to half minus, and here we have for f of x we can write x minus greatest integer of x, right? So here now we'll take x is equal to half minus h, right? So now here we have the point which is in the neighborhood of x is equal to half. So we have half minus h, right? So when x tends to half, obviously h tends to 0, and h is a positive quantity which lies between 0 and 1, right? So now we have limit, here we have h tends to 0, here we have a half minus h, and here we have greatest integer of half minus h, right? So now we have to evaluate this limit, right? So here we cannot directly substitute h is equal to 0, right? So here first we'll find out the value of greatest integer of half minus h, right? Now see, h is a positive quantity, it lies between 0 and 1, but h is infinitesimally very small, right? So this half minus h is greater than 0, but it is less than 1, right? So now it means that half minus h, it lies between 0 and 1, right? And moreover, half minus h is less than half, right? So half minus h lies between 0 and 1. So the value of greatest integer of half minus h is equal to 0, right? So here we'll write 0. So now the left hand limit is limit h tends to 0. Here we have half minus h, and here we have 0, right? So now this is limit h tends to 0, and we have simply half minus h. So now we can take here h is equal to 0. So we have half minus 0, that is equal to half, right? So the left hand limit is also equal to half, right? So from this discussion, we have arrived at this result that right hand limit is half and the left hand limit is also half. Now let us find out the value of the function at x is equal to half, right? So we are now finding out f of half. So f of half is the half. Here we'll take x is equal to half, and we have half minus greatest integer of half, right? And this is half minus 0 because the greatest integer of half, that is greatest integer of 0.5, is equal to 0 by definition of greatest integer function. So here we have half minus 0, that is equal to half, right? So the value of the function at x is equal to half is also equal to half. So viewers, from this discussion we have reached at this conclusion that the right hand limit is equal to left hand limit, and both the limits are equal to the value of the function at x is equal to half, right? And this is the condition for continuity of a function at a given point, right? So here the point is x is equal to half, right? So we can conclude that this function, that is the fractional part function, is continuous at x is equal to half, right? And always remember that here we have taken a non-integral point, that is x is equal to half, right? So in some other video we'll discuss the continuity of fractional part function when this point x is an integer, right? So here we have taken a non-integral point, right?